The first thing that people tend to ask about Rahu and Ketu is what calculation should I use? Should I use mean node or true node? These are the two, age-old ways to calculate Rahu and Ketu. One is mean node. Another one is true node. Now, mean node has been around forever. True node is a relatively recent calculation. And we don't have a lot in the ancient Hindu books to help us in figuring out which one of these nodes to actually use in practice, which one's better. The reason that is because in the old Hindu astronomy books, when they talk about calculating the planets, they use a completely different system for calculating the planets than we do. In modern, methods of calculating horoscopes, which have been common for, about 200 years now, even in India they've been more and more common for the past 200 years, is we use ephemeris tables. So we use very accurate tables with planetary positions every 24 hours, and then we interpolate the movement of the planet. And now with computers we even have more accurate ways of calculating planets that use ephemerises, but which do a lot more subtle calculations for the interpolations to make things more accurate. So that's not how it was done in India. In India, how they calculated planetary positions was they would start at the first day of creation. And yes, they actually have a record of when the Hindus believe the first day of creation was. And upon that day, all the planets were conjunct at 0 degrees of Aries. And then based on the mean motions of the planets, which is their average range of motion, they would basically tell us how many days it took for each planet to go through the zodiac once. And we use that information with how long it's been since the first day of creation to see how many times the planets have gone through and the fraction of time. And through that, find their mean position. And once we know their mean position through that, they would do a couple extra calculations to find their true position. And that's not a very accurate way to calculate the planets. That method works very well for a narrow time frame. So for instance, the calculations and the corrections given in the current version of the Surya Siddhanta, which has the most accurate planetary calculations in any of the Indian astronomical books, is most accurate at 1100 AD. When we use those same calculations today, 900 years later, the planets can be off by 2 degrees quite easily. And if we use those same calculations 1,000 years before, the planets would also be off a little bit. But the astronomers at the time knew that, and so regularly they would update those calculations so they would give accurate planetary positions for the here and now. But like I said, the last update was done, it seems, like 900 years ago, so they're just not that accurate anymore. Now the problem with the nodes, when they talk about calculating the nodes, that's how they do it. They say, Rahu, the node, takes this many days to move through the zodiac. It's been this many days since the beginning of creation, so now you can easily find out where the node is today. But we don't calculate planets out that way these days. We use planetary cycles, laws of gravitation, ephemerises, and all this really complicated stuff to get much more accurate positions. So based on what they say in the old books, they just say that Rahu's always moving backwards at this rate and determine its position based on the number of days that have passed since creation at that stable rate. Doesn't help us. The only thing we know from that is that nowhere do they mention Rahu going direct. Rahu and Ketu, the nodes, always go reverse. They don't go Aries towards Gemini, they go Gemini towards Aries. They're always going backwards. And the old books never give any reference or mention of Rahu and Ketu ever going forwards. Okay? Now, if we use the true node option, Rahu and Ketu will occasionally, in fact quite often, go forwards. So they'll go retrograde like normal, and every once in a while they'll go forwards. And so then we get them going backwards and forwards again. And people try to assign different meanings to Rahu and Ketu if they're going forwards and if they're reversed. Western astrologers are really big into that. I'm a firm believer in that Rahu and Ketu can never go backwards. I think that's just an error, which makes me not believe in true node, basically. And the reason that is because there's no mention of the nodes ever moving forward in any of the old ancient textbooks. So I never even thought they conceived of that being a part of Rahu and Ketu. Now most people use true node though. Why? Well, if you're given the option to use something that's mean or true, well naturally you're going to use what's called true, right? I would. I mean, that's what I used when I was uneducated. I used true node. Because it's true. It says so. It says true node right there. But the truth is, the true node is actually not true. Okay? They call it true node, but that's just what they called it. That's like calling a dollar bill that I print on my printer a dollar bill. It's really not a dollar bill just because I'm calling it a dollar bill, right? So true node is not true. Mean node, however, is mean, which means it just takes the average rate of motion. So I'm going to explain this a little bit more now. Okay? Again, review. What is the node? We have the sun. Around the sun, we have the earth traveling here. Around the earth, we have the moon traveling. Okay, and here, again, this plane extends into infinity. The moon's path intersects the earth's path. And this is true node, or this is Rahu, and this is Ketu over here. The intersections with the moon's path with that of the earth's path. That's the nodes. And this is always moving backwards. Okay? Now, what mean node does, it just assumes that the node travels at a certain rate, and every day, therefore, it moves this far through the sky. And they say, well, and this day it's here, this day it's here, this day it's here, and they just keep ticking it away, depending on how many days. Okay? And that's very similar to the way the ancient Hindus calculated it. The problem with mean node is that when the moon is exactly conjunct Rahu, or when the moon is exactly conjunct Ketu, the moon's latitude, so if you go and look at the latitude of the moon's latitude will not necessarily be 0 at that moment. But by definition, the node occurs when the moon intersects the plane of the ecliptic. This is the plane of the ecliptic. Well, the plane of the ecliptic has a latitude of 0. Therefore, the moon, when it's conjunct Rahu, has to have a latitude of 0. And the moon, when it's conjunct Ketu, has to have a latitude of 0. But with the mean mode calculation, it doesn't. It's close to 0, but it's not 0. So that means the mean node can't be right, because the moon has to be at 0 latitude when it crosses the ecliptic plane, which is what creates Rahu, which means at that moment it better be conjunct Rahu. Otherwise, it's creating something that's at a different point. That's not how it's work. That's not right. That doesn't work. So we know from that that mean node can't be perfect. Okay? But we also know that true node has a problem of going direct, going forward. And some people might say, well, maybe that's really how it should be, and maybe the Hindus just missed that point, and therefore they didn't mention it. But there's other problems with the true node. Like I said, the true node is not really true. It's just called true. What's happening with the true node is that they find the moon's position exactly when it conjuncts Rahu, where it has 0 latitude, and where it is when it's with Ketu at 0 latitude, which is what we want. That means these 2 points are perfect, which they're not always perfect when we use mean node. When we use true node, when the moon conjuncts Ketu, it's always going to have a latitude of 0. Or when moon conjuncts Rahu or Ketu, it'll always have a latitude of 0. And again, for those of you, what's latitude? Latitude, say this is the ecliptic. Let's take another view. Here's the sun, here's the earth, and this is the ecliptic. The planet's north or south of the ecliptic is its latitude. When the planet is right on the ecliptic, it has 0 latitude. So the moon revolves around the earth, and when the moon hits this line, that's Rahu. When it hits this line, it's Ketu. So then it has a latitude of 0. Okay, to see it in from another perspective. So, the moon has to have a latitude of 0, which it has with true node. Then what they try to do with true node calculations, which are pretty complex, they try to figure out where the momentary plane of the moon intersects the ecliptic. Okay, so momentarily plane. plane of the moon where it intersects the ecliptic. Now, the problem with this, there's two problems. One thing is the momentary plane of the moon. Well, the moon has a habit of wobbling a lot. In fact, one of the names of the moon in Sanskrit is the hair marked, like a rabbit. And they consider him to be marked or looking like a rabbit. And the reason is because compared to all the other planets, the moon basically jumps like this through the zodiac. So as it's going around the ecliptic, it's going up and down more than any other planet. You know, all the planets go up a little bit, gain latitude, then they go get a little less latitude. They all do that a little bit. But the moon does it in a radical way. So the Hindus thought of the moon as jumping across the sky. And so they called it a rabbit. And because of that, its momentary plane is constantly shifting and changing. And so they're trying to figure out where that plane is and therefore where Rahu is. And it's a theory. The calculation is a theory, not an actuality. Okay? So it's actually not true. The other problem is, because of the fact that as the moon rotates around the Earth, it has a gravitational pull on the Earth. Just a little bit. You know, mostly the moon is getting pulled by the Earth. But as the moon revolves around the Earth, it kind of jerks the Earth around. So when the moon's up here, the Earth gets jerked this way a little bit. And when the moon's down here, the Earth gets jerked this way a little bit. How much? By as much as 1 second maximum of arc. So it'll move the moon's gravitational pull will actually move the Earth up or down 1 second of arc. Hardly anything. But that 1 second, when it translates into figuring out the momentary plane of the moon, can come out to several seconds of arc of Rahu and Ketu. So your Rahu might be 9 seconds off. Now that makes a difference when you're using Varga charts, if it's in this Varga or that Varga. 1 second accuracy we can deal with, but you know, we get several seconds and we can have some serious interpretive errors, because we really want those nodes exactly where they are. And then the whole thing, calculating the momentary plane of the moon is the hypothetical calculation. There's no way of testing it. The only time we can actually test if the calculation is working is when the moon crosses the ecliptic and forms Rahu, and when the moon crosses the ecliptic again and crosses Ketu. So when it comes down to it, the only things we know that are true when it comes to node calculations is where Rahu and Ketu are right when the moon conjuncts them. Right when that moon crosses the ecliptic here, where did I show that? You know, right when the moon crosses that ecliptic, right when the moon crosses the zodiac belt and forms Rahu, that we know is true. And when it's over here, that we know is true. Everything in between is not true and will be off by a few seconds of arc at its very best. So the true node is not really true. And honestly, one of the reasons the true node goes retrograde is because this moon's habit of jumping north and south a lot, of moving up and down a lot as it travels. And that's one of the main reasons you get this big shift in Rahu going direct and then Rahu going retrograde. Okay, so the problem with calculating the nodes properly and why there's two different methods in the first place is because we only can actually find a node right when this moon crosses the ecliptic on Rahu's end and Ketu's end. Any other time we're trying to find a node, we're guessing. The only time they're really true, where they're actually an existing point, is at these two places. Okay? And both these have problems. Okay? The mean node doesn't work. The moon's not at 0 latitude when it conjuncts Rahu all the time, so it can't work. True node goes retrograde, or direct, which isn't right. True node can suffer by a few seconds of arc of error. And true nodes calculations are not true anyway. So, there's problems with this one. So there's an astronomer, his name's Dieter Koch, and he actually wrote the Swiss Ephemeris, which is the engine that does all the planetary calculations for Kala. And he's definitely the best person when it comes to programming astrological calculations, meaning the astrology part, you know, the astronomy part, where planets are, houses, and all that stuff. He's definitely the best person in the world for that. He also happens to be a Sanskrit scholar. So he's sort of a neat guy, even though he's a Western astrologer, not a Vedic astrologer. So, he wrote an idea. Let me clean this up a little bit. He had an idea that, because of these problems with the nodes that I just talked to you about, that maybe the thing to do is calculate out, I'll draw it this way, it's a little easier to see, I think. Okay, Sun, Earth, Moon. Okay, as the Moon travels here, when he moves up, he creates Rahu as he crosses the ecliptic. And as he's going south, he creates Ketu as he crosses the ecliptic. His idea is we find this point, and then we find this point, based on true node, because that's where it really is. That's when the true node is actually accurate. No other time is the true node necessarily accurate. But at these 2 points, the true node is perfectly accurate. So we find these 2 points, and then to find where the nodes are, what the moon's the rest of the times when the moon is not conjunct Rahu or Ketu, he simply sees how long does it take for the moon to go from here to here, to travel from Rahu to Ketu. How long does that take? Let's divide that time by 180 degrees, because that's 180 degrees of the circle. Then how long does it take for the moon to go from Ketu to Rahu? Let's take that time and divide it by 180 degrees. And through that, find a rate of motion for the moon and interpolate the moon's position accordingly. Okay? So basically, we're using the true nodes, and then we're finding the mean motion of the moon through that arc to find the point. So we're sort of doing a combination of mean node and true node, with the true node, when it's really true, at the conjunction of Ketu and Rahu, being sort of the foundation of a mean calculation. So one wise person said, when there's a controversy or where 2 people disagree, the answer is always somewhere in the middle. So if this is promising, because the answer is in the middle. It uses both ideas to come up with a whole new solution. Now, Dieter Koch never programmed that option, that calculation for Rahu and Ketu. He just talked about it and said this might be a more sensible way to do it. He never calculated it. He never tested it. He never wrote anything else on it. I haven't ever seen anything else on it. I think he's the first person to think about it. But maybe he learned the idea from someone else. I don't know. But if he does, he's usually really good about crediting where he gets ideas from. So I programmed this calculation into Kala, and I've called it interpolated true node. So if you're using Kala software, you now have another option for calculating Rahu and Ketu called interpolated true node. The reason I wanted to try his idea because it made sense to me, first of all, and second of all, I've never had what I thought was completely consistent results using mean node calculations or true node calculations. When I get into the Vargas where a few seconds of arc can easily shift Rahu or Ketu into a different Rashi, to a different sign, never felt like either of these calculations was doing it 100% for me. Okay? I'd find some charts that I thought worked better with true node, some with mean node, and some which didn't work like I wanted them to with either one. So I was really open to trying this new idea of interpolated true node. So that is an option in column. Basically, just to say what that option's doing again. We find the exact point of Ketu and Rahu, which each happen once every month, when the moon crosses the ecliptic. And this is the ecliptic, this line here. We find where Ketu and Rahu on those 2 periods. And the rest of the time, we just take the average motion of the moon to cover these arcs. And we interpolate the moon's position, or the Rahu's position at that time. So I've been using that method since I programmed it, which was, about 9 months ago, 10, 12 months ago now. And I'm liking it, but I haven't done as much testing on it that I want to say, this is the one that is definitively the better one. Having used these for years, the mean node and true node for years, and never being completely happy with either, I'd say I'm at least as happy with interpolated true node, maybe a little more happy, but I still need to spend time testing it a little more ruthlessly before I say use interpolated true node or die. So I'm not at that point yet. But I am using interpolated true node at this time. So the charts that we'll be looking at in any of these videos, or if I look at your chart, I'll always be using interpolated true node as I continue to work with it and test it. Now the difference between these three is very small. It's not a huge difference. The difference between mean node and true node can be up to 1.5 degrees sometimes, maybe sometimes a little more, but usually it's more like 15 or 20 seconds of arc. So in most day-to-day interpretations, whether a person uses mean node or true node won't really make a difference. But in the Varga charts, when people start getting to the subtle Vargas like the 45th Varga and 60th Varga, 20 seconds of arc, 15 seconds of arc can make a huge difference. Okay? And then we have to be concerned about this more. The interpolated true node is closer to the mean node than it is to the true node. And I actually used mean node before. That's what I've used for the past several years, mean node over true node. Okay? Interpolated true node is very close to mean node, just a little teensy bit different. It's not much different, okay? So that's what we're using. At some point, when I feel like I've worked with it enough to definitively say it's definitively better than these methods, or it's definitively worse than these methods, I'll let you know. But at this point, I'm liking the interpolated true node better than I am any of these ones, but I still feel that, you know, the 10 months that I've been having that calculation available to me is not enough to say definitively it can only be interpolated true node. But you all can play with it and see how you feel with it. Like I said, if you're just looking at Rashi chart and some of the basic Vargas, you might hardly come across any charts where it'll make a difference. And if you're just using the Rashi chart like a Western astrologer, it's hardly going to make a difference if you're using mean node, true node, or interpolated in 99 out of 100 cases. Just once in a long while it will make a difference. But if we're using Vedic astrology, where we're using the Vargas, like the 60th Varga, which is just 30 minutes long, at that point, you know, a 20-second arc, 30-second arc, or I'm sorry, a 20-minute arc can make a big difference. Because the difference between the mean node or true node and interpolated node can easily be 20 minutes of arc, 30 minutes of arc, which can change a complete sign easily in the Varga charts, in the smaller Varga charts like the 60th. Okay? So this is what we're using if we have Kala. If you don't have Kala, I definitely recommend you use the mean node over the true node. Okay? If you don't have Kala, use the mean node over the true node. And true node, because it's really not true, I feel and I found just through experience, I prefer that one the least. So if you have Kala, give interpolated true node a try. If you don't, use mean node. And then, you know, I'll let you know in the future as I work more with interpolated true node if I continue to keep liking it above these other two options. Okay? So now at least you understand the different options that are there and can sort of choose your own with a little bit of education. Because otherwise it's so easy just to think true node has to be right because it's called true. Well, I'm sorry, but it's really not true. So we're back to square one of trying to figure out